This lesson covers DNS zones. You have two different types of zone available, forward lookup zones and reverse lookup zones. A forward lookup zone enables you to translate a fully qualified domain name to an IP address. For example, I can see on my saviltech.net, I have many records that relate to IP addresses. A reverse lookup zone enables me to find the host name from an IP address. So for example here, this zone enables me to search for an IP and it will return the host name. You'll notice for a reverse lookup zone, the actual name of the zone has a special format. It's actually reversing the various bytes that make up the subnet. So instead of 192.168.1, it's 1.168.192.in-address-ARP. This is done for you automatically. If I create a new zone and say it's a reverse lookup zone, as I type in the subnet mask, notice it's actually filling out the correct name for me. So this is not something you have to manually do. The wizard will work this out for you. For each zone, it's responsible for a certain portion of the DNS namespace. So for example, I have a saviltech.net zone that's responsible for saviltech.net. And you will create these zones for each portion of the DNS namespace you need to list and maintain on this server. Now by default, when you create a domain controller, it will automatically create zones for the domain names you specify. I can manually create zones by using the New Zone wizard. Now there are a number of different types of zone. A primary zone is the master copy of the records that make up that zone. It's writable and is considered authoritative. I can also create a secondary zone. A secondary zone is a copy of the zone stored on a different DNS server. And while it can respond to requests for records in that zone, it cannot make any changes. Any changes must be sent up to the primary holder of the zone. So you have this relationship of primary and secondary. The reality is, secondary zones are not used frequently in Active Directory enabled environments anymore, as they were really used in the time before Active Directory integration, where the Active Directory couldn't be used, and so the DNS information was stored in a file. And the way this worked is the primary zone's file was stored and could be written to. A secondary zone copy on a different DNS server pulled the contents of that file over, cached it, and then serviced the records, and then periodically would pull down updated versions to keep it synchronized. Now what we can do today is say to store in the Active Directory. This then utilizes the multi-master replication capability of Active Directory to remove the need for read-only copies. So normally you are going to create a primary zone and store it in the Active Directory. We also have the option to create a stub zone. So a stub zone is a special type of zone that only contains a subset of records from another DNS zone that's stored on another DNS server. It basically only stores the records that allow me to know which DNS server is authoritative for that zone and what those host records are. So for example, consider a scenario where maybe my company merged with another company and that company had its own DNS servers. And rather than have to traverse the internet, go to the root, the com, etc. to find that server, when I needed to query that server, I wanted a shortcut in effect to find the name servers for that domain. Well, I would create a stub zone, and that stub zone would automatically replicate from that server, that primary server for that other company, those name server records, those start of authority that tell it, hey, I'm authoritative for this domain. So stub zones are something you're going to manually create if you need to really improve the resolution of name records to zones stored on other DNS servers, for example, as part of your company or a partner company. Now, when I select to store in the Active Directory, I have different options for how they are stored. Now, this was introduced in Windows Server 2003. Prior to Windows Server 2003, if I stored DNS information in the Active Directory, it was just replicated to all domain controllers in the domain, whether or not they were actually DNS servers. 2003 Active Directory introduced the concept of directory partitions, i.e. separate from the Active Directory information, which allowed separate partitions to be configured for DNS replication within the domain and DNS replication for within the entire forest. So I can now actually select should this DNS zone be replicated to all domain controllers in the entire forest, to all DNS servers running on domain controllers in just this domain, or to just all domain controllers in this domain, i.e. whether or not they're running DNS. Now behind all of this are those partitions. So for example, I can actually see those. I can say DNS command, enumerate, directory, partitions. And this shows me these are those two special zones, domain DNS zones and forest DNS zones. The good news is when you create your Active Directory domains, the domain controller promotion wizard automatically sets the most logical option. For example, for your domain zone, it automatically sets it to be AD integrated and to replicate it to all DNS servers in the domain. Now you'll also notice there is a separate zone created. And this is actually replicated to all DNS servers in the forest because this contains records that are of forest interest, information about the global catalog, the primary domain controller FSMO emulators. So again, it automatically creates these separate zones for the most logical replication. When you're creating your non-Active Directory domain zones, you should use whichever makes the most sense and for how you want them replicated and who is going to host those. The good news is once you create those zones, it's now automatically replicated using standard Active Directory replication. So within a site, it's going to replicate very, very quickly any updates. Between sites, it will follow whatever the Active Directory site topology replication is that you've already created. Separate from sites, I should also point out you do have this conditional forwarder capability. So I talked about stub zones, a special type of zone that imports in those start of authority and name server records. I can also say for these certain DNS domains, rather than just forward those out to my general forwarder or go and browse them on the internet, for this specific domain, so I could say infinite skills, for example, actually forward it to these specific DNS servers instead. And again, I can say store this in Active Directory, which will then replicate it to all my DNS servers in AD. So this gives me more options to configure how that Active Directory and DNS lookup process actually works. In this window here, I fired up ADSI Edit. ADSI Edit lets me actually query the data stored within Active Directory. So I've actually connected to the domain DNS zones partition stored in Active Directory. So this is easy to do. You just do connect to and you type in the path. So for example, I did DC and I'll actually connect to the forest as well. Forest DNS zones and then my domain DC equals Saviltech, DC equals net. Now I didn't give it a proper name, but you can now see I can see my forest DNS zones. And I can actually see all those records. So this is how it's stored in Active Directory. All of those records and data is just stored and replicated through Active Directory. And again, this is really your preferred approach for anything where you're storing DNS and running that service on domain controllers. It removes the need to manually use primary and secondary zone files, which actually reduce your functionality by having those copies that are read-only and actually are more complicated to manage. I should point out, however, if you use read-only domain controllers, which are a special type, then you do also have read-only DNS on those servers to match the capabilities of Active Directory.